Hello, my name is Chen Goldberg. I am the Chief Cloud Architect and one of the founders at CloudWise, a company that helps CloudOps teams to regain observability and control over the ever-changing cloud architecture. Today, I'm going to talk about the observability in the different cloud environments. What does observability mean and how to achieve it by going through some relevant use cases and the different cloud services that are offered by the cloud providers. So we have a lot to do in a short amount of time. Let's jump into the slides. Before we dive into discussing observability, let's take a minute to understand what observability is. Some background. I first encountered this term back in 2013 in a Twitter blog. Back then, there were a lot of discussion about moving from a monolith architecture to distributed architecture and how to monitor your architecture ops, but monitoring wasn't enough. Then this question was raised. What the difference between monitoring and observability? According to Wikipedia, observability is the measure of how well internal states of a system can be inferred from knowledge of its external outputs. From my point of view, observability is a property of a system to which a team or a company values the ability to inspect and understand systems, their workload, and their behavior. Observability can help in the more proactive identification and division from expected behavior before it becomes an issue that can disrupt services the new way many companies start to work. Moving to a distributed system architecture consists of thousands of services and configuration. Those companies also want to be able to scale rapidly. So they are moving to the cloud, which enforces them to use more capabilities of analyzing and understanding the root cause of a failure in their system. It is not enough using logs or monitoring tools to understand the cause of the problems. It takes a combination of several tools. When talking about observability, we should talk about the three pillars that observability is comprised of. The first, logs. Logging is a mechanism of collecting logs from various input sources. Usually logs are in raw format. To gain real insights, we need to parse these logs and apply query type in order to gain insights quicker. Usually logs are sent to an output tool which organizes the logs. The second pillar is metrics. Metrics are numeric representation of data, measured over intervals of time. Metrics can harness the power of mathematical modeling and prediction to derive knowledge of the behavior of system over intervals of time in the present and future. The last pillar is trace. Trace is representation of a series of causally related distributed events that encode the end-to-end request flow through a distributed system. So there are the three basic pillars: logs, metric, trace. During the past few years, some claim there is even a fourth pillar, adding visibility as another pillar. Some even consider chaos engineering to be part of observability pillars. It seems like the polyglot architecture creates more and more layers that need to be added in order to correctly understand the behavior of the system, what finally defines the word observability, understanding why the system behaves like it does. We explain the term observability, and we can spend hours talking about it in many points of the system lifecycle process. But we are limited in time, so today I want to talk specifically about observability in the cloud and how we can best achieve it. Let's take a second to understand the cloud service model. The image explained what are the layers of the cloud model and their responsibilities are. As you can see, the cloud divided into the parts the customer manage and the part the provider manage. Each one of the layers in the model have one or more tools we need to have in order to collect, analyze, detect, resolve, visualize, in order to manage and gain the control of the layer. In order to understand the challenges of observability in the cloud, we need to understand which layers of the architecture stack are under our responsibility. Don't get confused. When you are responsibility for some layers, it comes with a price of control and requires the use of additional tools to gain the needs of observability. Fact of the matter is that when handling high-scale cloud architecture, it's almost impossible not to use managed services. We can see that the models sometimes expanded. In the picture, you can see the evaluation of the microservice architecture influence of the layers of the cloud deployment models by expanding the option we have, containers, serverless, etc. Each model has different tools of implementation in order to gain the observability we want. One important thing to remember is that each layer becomes more flexible with more features. It is also making the system more complex to observe. You can see in the picture below the complexity of distributed systems consists of a lot of cloud services. When we first used just few services, it was very easy to gain control. But as we added more and more services, we start to lose control, and the ability to observe correctly our architecture forces us to spend more time and efforts. Every service in the cloud has its own configuration, limit, price, connection, and availability that is different between each cloud providers. We need to include those parameters in our observability of the system. When talking about cloud architecture observability, I usually divide it into these 5 pillars: performance, operation excellence, security, cost, and compliance. Most companies realize this is a big issue and build the dedicated teams to handle this. So it's no longer the responsibility of the ops or R&D to gain observability of the cloud architecture. It's one of the company goals. DevOps, DataOps, CISO, SRE, CloudOps, DevSecOps, legal, DevTools, etc. People with these titles are part of the dedicated team. In my opinion, the name of this team should be Observability Team. Now I want to talk about the services in the different cloud providers and show how we can gain this observability we wish using them correctly. Let's start with the AWS services. CloudWatch is a core product inside AWS that focuses on the activity of AWS services and resources. CloudWatch reporting on the health and performance of the services and logging all the events from the particular service or application. You can refer CloudWatch service as a repository for all metrics from a different sources, give you the ability to retro-review statistics based on those metrics, and even send alarms based on those data parameters. Let's take a simple example that is related to one of the 5 pillars we talked about earlier, cost. From a day of FinOps, we want to right-sizing all our EC2 instances in our AWS account for cost reduction process. So first, we want to check if all our EC2 are using the right EC2 instances type and family. To do that, we need to collect all the metrics of the EC2 instances, such as CPU, memory, IOPS, etc. Now, if we have all the metrics, we can calculate statistics and then present the data graphically in the CloudWatch console. Next, we can configure alarm action to stop, start, or terminate the EC2 instance when certain criteria are met, such as instance that not in use for a long period of time. And in addition, you can create alarms that initiate Amazon's simple notification service, what's called Amazon SNS. Action on your behalf, such as let me know if there is an instance that the CPU is under 30% for the last month. In other use cases related to other pillars, like performance, we can also create alarm that initiates Amazon EC2 auto-scaling when our application need to be scaled up or down related to the different metrics. Let's see another use case related to CloudWatch from a security and compliance pillars perspective. This scenario in the picture describes how to monitor and visualize failed SSH access attempt to EC2 Linux instances. You can see that CloudWatch logs that is reported on application logs have agent that running and configured to send SSH logs to a log stream. We are using the metrics filter on the log group to find specific keyword and use CloudWatch alarm when we found a match. An IAM rule that gives the EC2 servers permission to create logs in a log group and send log events from EC2 to log groups. CloudWatch alarm notify users when a specific threshold has been crossed. For example, you can set an alarm to trigger when more than 2 failed SSH connection happen in a 10 minutes period with SNS, the AWS Send Notification Service. The CloudWatch dashboard is used to visualize data and alarm from a monitoring process. It's important to know that AWS CloudWatch is a regional service, and if you want to aggregate data from all regions together, you can do it with the CloudWatch cross-region functionality to aggregate statistics and different regions. Now let's talk about CloudTrial service. AWS CloudTrial is mainly concerned with who did what on AWS and when and from where. With CloudTrial, you can log continuously monitoring and retain account activity related to the action across your AWS infrastructure. CloudTrial provides event history of your AWS account activity, including action taken through the AWS Management Console, AWS SDKs, command line tools, and other AWS services. This event history simplifies security analysis, resource changes, tracking, and troubleshooting. Let's see an example of how AWS CloudTrial can help us track changes in IAM policy. So in the picture, we'll see a sample of using CloudTrial to gain observability on the security and compliance pillars. IAM service plays an important role in AWS account management. Sensitive information like password, RSA keepers, and stored, they are stored on AWS for application use. In most of the cases, this sensitive information should only be accessed by the application deployment. However, there could be certain scenarios which requires application developers or support team to access the information for debugging certain scenarios. These events need to be reported for auditing and compliance purposes on production environments. This information regarding AWS Resource API access is available in CloudTrial. However, many teams struggle to extract the information from CloudTrial and present it in terms of alerting whenever the restricted resource is associated on AWS. The above sample flow will capture the CloudTrial event that has specified values that from our point can be suspicious. The CloudTrial will trigger Lambda that will process these logs and push a message to SNS, which will consume by Slack alert Lambda to send notification on Slack. And you can see the whole flow in the picture. Let's move to the AWS service that's used for tracing in distributed system, AWS X-ray. AWS X-ray is a tracking service, tracing service, makes it easy for developers to analyze the behavior of their production distributed application with end-to-end tracing capabilities. You can use X-ray to identify performance bottlenecks, edge case error, and other hard-to-detect issues on a complex distributed application built using microservice architecture or serverless architecture. This enables developers to quickly find and address problems in their application and improve the experience for end user of the application. We can use this service to observe issues with the performance pillars while trying to understand latency problems in our architecture. Let's see another service in AWS VPC Flow Logs. This service captures information about the IP traffic going to and from network interface in VPCs. The logs allows you to investigate network traffic pattern and identify threats and risks across your VPC environment. Flow logs data is stored using Amazon CloudWatch logs. In the architecture flow described in the picture, you can see how we build observability architecture for the flow logs by using AWS managed services such as Amazon Kinesis Firewalls, Lambda, S3, Amazon Athena, and Amazon QuickSight to collect stored query and visualize the flow logs. If we had more time, I would have shown you how you can optimize the observability architecture, use the Lambda function to automatically partition Athena data in arrives from S3. That's improved query performance and probably going to reduce your cost. That's architecture flow show you how we can always improve the way our system behave and adding more effective tools and improve the observability of our system. AWS Transit Gateway provides statistics and log that are then used by services such as Amazon CloudWatch and Amazon VPC Flow Logs. It's also called Amazon Network Manager. You can use Amazon CloudWatch to get bandwidth usage between Amazon VPCs and VPN connection using the Network Manager. Packet flow count and packet drop count. You can also enable Amazon VPC Flow Logs on AWS Transit Gateway, so you can capture information on the IP traffic routed through the AWS Transit Gateway. Network Manager, monitoring the quality of your global network, both in AWS and on premises. You can see it have a map that describes all the connection and visualize it very well. There are a lot of services that can help us achieve the observability of the system regarding to the 5 pillars we discussed. Unfortunately, I don't have time to go over all the services, but I do want to show you what are the similar services in the cloud providers in order to give you perspective on how sometimes it will be complex to observe more than one cloud environment. Let's jump to Azure Cloud Provider. In Azure Cloud Provider, most of the services that logging, metrics, tracing is under the main service, Azure Monitoring. Azure Monitoring collects monitoring telemetry from a variety of on-premise and Azure sources. Management tools such as Azure Security Center and Azure Automation also push log data to Azure Monitoring. The service aggregates and stored this telemetry in a log data store that's optimized for cost and performance. Analyze data, set up alerts, get end-to-end views of your application, and use machine learning-driven insights to quickly identify and resolve problems. Azure Application Insights is one of the features of Azure Monitoring. Is an extensible application performance management service for developers and DevOps professionals. Use it to monitor your live application. It will automatically detect performance anomalies and includes powerful analysis tools to help you diagnose issues and to understand what users actually do with your application. You can see Azure Essential. Azure Essential is a scalable cloud-native security information event management, was known as SIEM. and security orchestration automated response solution. Azure Essential, delivery intelligence security analytics, and threat intelligence across the enterprise, providing a single solution for alert detection, threat visibility, proactive hunting, and threat response. It helps you observe your architecture in the security and compliance pillars. Azure Network Watcher provides tools to monitor, diagnose, view metrics, and enable or disable logs for resources in the Azure virtual network. Network Security Group Flow Logs is just like VPC Flow Logs in AWS, is a feature of Azure Network Watcher that allows you to log information about the IP traffic flowing through the network security group, just like we talk about in the AWS VPC Flow Logs. Azure Automation delivers a cloud-based automation and configuration service. It provides us change tracking into your architecture. You can see nodes that have deviated from their assigned configuration. You can monitoring and automatically update machine configuration across physical and virtual machines. Let's talk about some the observability tools in Google Cloud. Google Cloud Operation Service, it's the same like Azure Monitoring. What was known until lately as Stack Driver. It's like Azure Monitoring, and the service bundle inside all the features for log, monitoring, debug, tracing, and profile. When you go inside the console, you can see that the logging, monitoring, debugger, tracing, and profiler is under the cloud operation, Google Cloud Operation. In the picture, you can see a use case from a FinOps point of view, just like the AWS example we showed before. This service uses Cloud Profiler as a continuous CPU and heap profiling to improve performance and reduce cost. You can see that you can get a visibility, deep visibility of the CPU and the performance. In this table, you can get summarized of list of some of the services the cloud providers have in order to understand the cloud stack services behavior in all the 5 pillars perspective. We managed to cover most of the services that the different cloud provider has and the different implication each one decide to do on the observability core services, logs, metrics, trace. We also noticed that during the evaluation of the deployment strategy and the expanded of the cloud services suggested by the vendor bundle into one main service, such as AWS CloudWatch Service Lens, Azure Monitor, GCP Operation. This action by the cloud providers, leaving the users with less overhead and configuration needed to be done to aggregate all the data is happened because it's very complex to track all the update and limitation of the services. We wish to have one solution that will help us to manage the observability core tools seamlessly on all the 5 pillars: cost, performance, security, compliance, operation, excellence. So we got to the end, and I hope I managed to help you understand the meaning of observability in the cloud architecture and the different services the cloud offers to help you gain that observability. The main takeaways I would like you to take from the lecture would be the following. First, when evaluating your cloud architecture environments, enabling observability by using change tracking inside the environment is very important. When building an observability around the cloud services themselves, don't forget to follow the 5 pillars, and remember that sometimes There are trade-offs between them, for example, cost and performance. Keep update with the cloud provider observability service limits and new features. It can expand all your observability system and can save you time, money, and resources. Collect what's important and save the data wisely. It can help you a lot, but don't forget that data storage in the cloud has a price and it's not free. The cloud metrics and the logs event can tell us a lot about our system and help us build the timeline of our system. Knowing what happened in the past can probably help us to better prepare for the future and not repeat the same mistakes again. Build many scripts to observe your system is sometimes hard. Use managed services to save time and maintenance effort. Developing script to handle the observability isn't a simple task, and it requires time, resources, and maintenance. So keep in mind there might be a service by a third party that can help you do that in more effective way. Try to build a proactive rules and policy in order to prevent and reduce time analysis of a failure of your system. Create a custom graph of your architecture need. It can help you gain observability faster. That's all. Thank you for listening. If you have any question, I'm here. Thank you very much.